Okay, we're going to start the notes for 7.6. So again, we're going to be solving equations, but we're going to be looking at special equations called proportions. So if you have a proportion, so a proportion is two fractions that are set equal to one another. So a proportion would be, and we're going to complete it here, A over B equals C over D. That would be a proportion. It's two ratios, which are fractions, that are set equal to one another. And when you have a proportion like this, you could use a small shortcut to be able to solve. So you don't have to multiply through by the lowest common denominator like we did before. You can cross multiply. Hopefully you've heard of cross multiply. So you can see that if we look over here at cross products, if you have A over B equals C over D, then A times D, so that's why it's called cross multiply, is equal to B times C. So notice how it eliminates the fractions. So it's just a different way of doing it. All right, so if we look at 1a, we can see that we are looking at a proportion. It's a fraction equals a fraction. And because it's a proportion, we can solve by cross multiplication. So when I go this way, I'm going to get 3 times x is equal to, if I go this way, I'll have 8 times 63. Well, use your calculators to find that 8 times 63 is 504. So now I have 3x equals 504. Let's divide both sides by 3. And x would be equal to 168. And it's that simple. So again, you can use cross multiplication whenever you are looking at a proportion. A fraction equals a fraction. Like you are looking at for B, you have a fraction equals a fraction here. So if I cross multiply going this way, I'm going to get 3 times x plus 2. You'll see that we're going to have to distribute in a minute. Is equal to, when I go the other way, I'm going to get 5 times x minus 1. And I can go ahead and distribute and solve. So we'll have 3x plus 6 equals 5x, be careful, minus 5. If I subtract 5x from both sides to get all my variables to the left, I'm going to get negative 2x plus 6 equals negative 5. Let's subtract 6 from both sides. I'm going to kind of slide up over here to the left. So when I do that, I'm going to get negative 2x equals negative 11. And then divide both sides of my equal sign by negative 2. And fractions happen. 2 negatives, when divided, make a positive, and you can just leave that as 11 over 2. So an application that we have of working with proportions is looking at two geometric figures that are similar. So this may sound familiar to you. I know we do similar in Math 47, if you've had Math 47. What similar figures mean basically is it's that they're two shapes that have the same shape, like two triangles or two rectangles, but not necessarily the same size. So for example, these two rectangles right here would be similar. They have the same shape, but not necessarily the same size. So what it really means geometrically for triangles or for any pair of geometric figures to be similar is that their corresponding angles are the same. So you can see that those angles, well, that's a rectangle, so they're both right angles are the same. These are corresponding because they're at the same place in the rectangle. And then, in fact, all pairs of corresponding sides will be 90 degrees. So when you have two similar figures, the corresponding pairs of sides or of angles are equal. The corresponding sides have the same ratio. So they have, maybe the ratio is 2 to 1, maybe the ratio is 3 to 5, whatever that is, they have the exact same ratio. Okay, so how does that come about when we have a problem, something like this? So if you look at number 2, first of all, I'm telling you that the two triangles are similar. So that means that the angles are the same. That's quite honestly irrelevant here. We are going to be looking for the length of side N. So what we're going to do is we're going to set up a proportion. So notice how we are given these two corresponding sides. That means that the ratio of the sides is 5 to 12.5. So that's going to make up our very first fraction. 5 to 12.5 is equal to, now the 5 is representative of the smaller triangle and the 12.5 is representative of the larger triangle. Since the 5 is on top here, we have to make sure that the smaller triangle number is also on top on the other side. So that's going to be a 3. And what side in the big triangle does the 3 correspond to? It corresponds to the N. So once again, 5 over 12.5 is equal to 3 over N. So the tops represent the smaller triangle, the bottoms represent the larger triangle. And now, look, we're ready to go ahead and cross multiply. So going this way, I get 5 times N is equal to, if I go this way, I have to do 12.5 times 3, which is 37.5. Go ahead and get the N alone by dividing both sides by 5. And 37.5 divided by 5 is 7.5. So the length of side N is 7.5. And there you go. So it also, proportions also lend themselves to something that we call shadow problems. And shadow problems are fairly simple. So let's go ahead and let's read this story problem all the way through. So a flagpole casts a shadow, thus the name shadow problem, of 25 feet. At the same time, a tree that is 6.4 feet tall casts a shadow of 8 feet. And our question is, how tall is the flagpole? Well, let's draw a picture of what's going on here. There's the ground. So we have a flagpole that is 25 feet high. So this height is 25. Okay. Now we also have a tree, there it is, that is 6.4 feet tall. It's a rather small tree, isn't it? So this distance right here is 6.4. And that tree casts a shadow that is 8 feet long. Well, think about it. Where is the shadow? The shadow is on the ground. So that distance right to there is 8 feet. Notice if I draw this line, what have I just made? I've made a right triangle. Our question is, how tall is the flagpole? So I actually labeled this incorrectly. Everybody notice that I put the 25 in the wrong place? Because it says the flagpole casts a shadow of 25 feet. So that is 25 feet down there. Hopefully you caught that. And our question is, how tall is the flagpole? So we're looking for that height. I just put an X there. And again, if I draw a similar line segment right there, you can see what I have now is I have two triangles that, by the way, are similar. And I can find my missing side, my X, by setting up a proportion, just like we did in number 2. So here we go. X over 6.4 is equal to 25 over 8. So the X and the 25 both represent this first triangle, And the 6.4 and the 8 both represent the second one. Go ahead, pause me, and cross multiply and see if we get the same answer. So if I cross multiply, I'm looking at 8x equals, we have 6.4 times 25. That's 160. Well, that's convenient. Dividing both sides by 8 to solve for x. X is going to equal 20. 20 what? Well, it says, how tall is the flagpole? And since everything is in feet, we must be talking about 20 feet. Always make sure in a story problem you label your answer if appropriate. Okay, 2 more story problems. The next one is just a basic story problem, and it's just going to have some division there. So the quotient, there you go. Remember, quotient means the answer to a division problem. The quotient of a number and 2 minus 1/3 is the quotient of the number and 6. So what are we looking for? Notice it says define my variable. I'm looking for the number. So let's just use n. So n is going to equal the number. So now let's come up with our equation. So the quotient of a number in 2. Well, that's going to be n divided by 2 minus 1/3 is, so that's equals, the quotient of the number and 6. Well, how do I write the quotient of that number n and 6? It would simply be n over 6. So now notice this is not a proportion. It has an extra fraction in it, so we cannot solve this by cross multiplying. So we have to go ahead and we have to multiply every term by the lowest common denominator. The lowest common denominator is 6. So we're going to take n over 2 times 6 over 1 minus 1/3 times 6 over 1 equals n over 6 times, guess what, 6 over 1. So we're using the method that we learned in 7.5. Now when we're done with this, all of our fractions should cancel. So 2 cancels into the 6 3 times, leaving me with 3n minus, here the 3 cancels into the 6 twice, so 2 times 1 is 2, is equal to, here the 6's cancel, leaving me with simply an n. So how about if we go ahead and subtract 3n from both sides? So that's going to give me -2, oops, not -2n, -2 is equal to -2n. Dividing both sides by -2, I'm getting n is equal to +1. So the number, there's really no way that we can go ahead and we can label that, but the number that we're looking for is +1. All right, this last problem we're going to do is something called a work problem. And work problems are classic problems, just like shadow problems are when we are working with rational equations. So Andrew and Tim volunteer at a local recycling plant. Andrew can sort a batch of recyclables in 2 hours if he's working alone, while his brother Tim can do that same thing, but it takes him 3 hours. He's slower to do the same job. If they work together, how long will it take them to sort the batch? Now, I like to use a chart here. Remember how we used charts in chapter 2 a lot? You don't have to. Go ahead and look in the book and see how they do it. I like this. So who are we talking about? We're talking about Andrew and we're talking about Tim. Okay, so our first column, we're going to label unit work. Unit work. Now let's talk about what unit work is. It's the same type of thing as unit price. So let's say that I can grade some papers in 2 hours. My unit work would be, I would grade 1/2 of the papers per hour. let's say I can grade those papers in 5 hours. That means my unit work is 1/5 because I can do 1/5 of the papers per hour. Let's say it takes my husband 3 hours to mow the lawn. That means that his unit work is 1/3 because he does 1/3 of the lawn per hour. So the unit work is 1/over the time it takes to do the job. So since it would take Andrew 2 hours to do this job alone, his unit work is 1/2. Tim's unit work, because it would take him 3 hours to do the job alone, is 1/3. So that's what unit work is. Now let's talk about the time, because that's what's going to be next. Well, let's see. Time is the time that it takes them to do the job. And if they're working together, I hope you can agree that the time is going to be the same, because they're going to begin the job at the same time, they're going to end the job at the same time. And by the way, that's what we're looking for. How long will it take them to sort? That should be one batch. So that would be a T and a T. Now, in every single story problem I told you, we worked with it. How did you get the last column? You always multiplied the first two. This column is work done. It's how much work they are doing. So Andrew's work done would be 1/2 times T, which is T/2. This is the part of the recycling that Andrew did. For Tim, his part of the recycling that he did is T/3. So I just multiplied T/1 times 1/3. Okay, so now we're again, just like always, going to use the last column to set up our equation. If this is the part of the job that Andrew did, and this is the part of the job that Tim did, what they did together is one full job. So we're going to take T/2 plus T/3 and set it equal to 1. When you set up your problems like this, you always set it equal to 1, because together they do one full job. Whatever it is, roofing a house, sorting recycling, grading papers, it's one full job. All right, so if we go ahead and solve this, we can see that our lowest common denominator is 6. So I'm going to take each fraction and multiply it by 6/1. So I'm going back to my previous section and using what I learned. So the 2 will cancel into the 6, 3, which leaves me with 3 times T, plus the 3 cancels into the 6, leaving me with 2. So that leaves me 2 times T is equal to 1 times 6 is 6. 5T is equal to 6. And if I divide both sides by 5, I get T equals 6/5, which is 1 1/5. Now remember that represents time, so it's 1 1/5 hours. Does that answer make sense? If it takes Tim 2 hours to do it alone with help, it's going to take him less than 2 hours. So 1 1/5 hours makes sense. And there you go.